This video will go through the process of filling out section number 3 of your flipbook titled Unit 2, Polynomials. This is the bottom flap of section number 3. And the title of this flap is Special Case Polynomials. And the reason I'm going to cover these with you is because if you see these types of expressions, there's a shortcut, there's a faster way to distribute those. You don't have to go through the entire process of either grouping, distribution by grouping, or distribution by FOIL method. You can actually go right to the answer because there's a shortcut, because they'll all basically work the same way. If you see something like this, it'll always have the same format of an answer, x minus 2 quantity squared, same format, and the same with this one. Now, if you don't remember any of these shortcuts, it's okay. You can go through the entire process just like we've already learned, distributing by grouping or distributing by FOIL, but just to save you some time, if you can remember that there is a shortcut on these. Now, this particular expression, x plus 2 quantity squared, that is actually two binomials being multiplied together. Remember that if I told you that my expression is x squared, you all know that that just means x times x. This exponent is just like a duplicator. It means write the value of x twice and multiply them together. Same thing here on this question. X plus 2 quantity squared just means take the binomial x plus 2 and write it down twice and multiply it. Multiply the two binomials together. So x plus 2 quantity squared means x plus 2 times x plus 2. Let's go through the grouping method that we've already learned. We're going to put a parenthesis around this second binomial. We're going to keep it together for now. We'll multiply the first term of the first binomial times the second binomial, and the second term of the first binomial times the second binomial. And we'll get x times x plus 2, and then we have positive 2 gets distributed to the second binomial, x plus 2. Alright, now we have two monomial times binomial situations. All we do is distribute this monomial to the two terms in the binomial. Same thing here, monomial to the two terms in the binomial. We end up with x times x is x squared. X times positive 2 is positive 2x. Positive 2 times x is positive 2x. And positive 2 times positive 2 is positive 4. Now, take a look at what we just ended up with. Notice these middle two terms, plus 2x and plus 2x, they're the same. They're equal to each other, and that will always be the case when you have a binomial times a binomial, and the two binomials are identical to each other, and they have a plus sign. So we're going to call this the positive case because, oops, let's write that correctly, because we have a plus sign. So let's write this as positive. Alright, so we can combine those two middle terms, and our final answer will be x squared plus 4x, 2x plus 2x is 4x, plus 4. Now class, this final answer here, I'll just put this as a final answer, I'll put a star there. This final answer has a format that will always be the same when you have this type of special case polynomial. The first term of your final answer, which is a trinomial, this is your distributed expression. The first term is always going to be the first term of your binomial squared. The last term is always going to be the last term of your binomial squared. And the middle term is always going to be this last term squared times x. So you can see 2 squared is 4 times x. 2 squared, there's 4, and x squared is x squared. So down here in the dashed lines, if you want to write this down, this is what it looks like with all variables. If you have a binomial, let's say two variables, x plus c, quantity squared, the first term of your distributed trinomial will always be the first term squared. The last term will always be the last term of your binomial squared, and the middle term will always be 2 times this value of c, this constant right here, 2 times that, times x. And one more thing, if you want to write this down for later, we'll be dealing with binomials where it's not just x. This might have a coefficient of 2 or -3 or 5 in front of it, so 5x plus 2. This form, or this base equation, shows you how that will work if you had a value of a in here, if you had a coefficient on the x which is other than 1. Alright, so shortcuts. Let's take a look at the next one. Again, we know that x minus 2 quantity squared just means take the binomial x minus 2 and write it twice. Multiply it times itself. Let's go ahead and distribute by grouping. So the x goes to the x minus 2, the -2 goes to the x minus 2. And we end up with x times x minus 2, and now it's a -2 times x minus 2. -2 times x minus 2. We'll now distribute these monomials to both terms in the binomial. And we end up with x squared. X times -2 is -2x. -2 times x is -2x. And -2 times -2 is +4. Okay, notice that the previous example and this example are exactly the same, except for look what changed here. This is the negative situation. It's a binomial with a subtraction or a negative number in it. And the only thing that's changed is, take a look, first term is the same, x squared. Last term is the same, +4. But the middle two terms, now instead of being positive, they are now negative. So our final answer is going to be x squared minus 4x plus 4. -2x minus 2x is -4x. Here is our final distributed answer, which is a trinomial, 3 terms. And the only difference is this middle term, same coefficient, same x, but now the sign of the coefficient is negative instead of positive. So here is our form or our shortcut for a special case polynomial where the binomial has a subtraction in it. X minus c quantity squared is equal to, there's our first term, take the x term and square it. Our last term, take the c term and square it. Notice it always turns to positive. And the middle term is going to be -2 times the value of c times x. And of course here is a little more complex example. If we ended up with a coefficient on x other than 1, then this would be your shortcut form. Okay, last one. What if we have a binomial times a binomial, but in this case the constant value now has opposite signs. Here it's x plus 2 and x minus 2. You'll see this lots of ways. Could be x plus 5, x minus 5, x minus 15, x plus 15. Instead of both the signs being the same, like in this case, plus and plus, in this case, minus and minus, we've got a plus and a minus. Let's see what happens here. Let's go ahead and distribute by grouping. So the x value goes to our binomial and the +2 value goes to our binomial. And we end up with x times x minus 2. And now we have +2. +2 goes to the, let me correct that because I kind of wrote it messy. +2 times the second binomial x minus 2. Alright, let's go ahead and distribute. Monomial to first term, monomial to second term, monomial to first term, monomial to second term. X times x is x squared. X times negative 2 is minus 2x. Positive 2 times x is positive 2x. And positive 2 times negative 2 is negative 4. Now take a look at what's happened here. A little bit different than the first two examples. These middle terms are like terms. They both have the same variable with the same exponent, but the signs are opposite. And that means these middle two terms in this type of polynomial or this type of binomial times binomial will always cancel themselves out. No matter how you work this, if you have x plus 5, x minus 5, the middle two terms will always cancel themselves out, and we'll just be left with the first term, x squared, and the last term, minus 4. So here is our special case shortcut. If you have two binomials with the same first term, and the second term is the same, just that the signs are opposite of each other, middle term goes away, and here is our format for that. If you have x plus c times x minus c, the first term of our final answer is just the first term here squared, and the second term is negative, and the second term squared. So negative c squared. Notice here, c is, we could call c 2. This is 2 squared is 4, and there's a minus sign there. And again, here's a little more complex situation. If we happen to have a coefficient in front of the x term, it'd be something like this: 3x squared plus 2 times 3x squared minus 2. You can follow this rule. I will start a next video. We're going to do the last part of this page on a separate video.